For the next topic, we have the electrolysis. So this is actually the effects of electric current in chemical solution. So what you basically does here is just you will apply an electric current into the chemical solution. So we have the formula here, M, which is the mass, is equal to ZIT or equal to ZQ. Okay. So that will be what happens here is that's why it became Q. Q is actually the charge. So ampere times a time is actually a charge. Okay? So I here, or the capital I, should be capital I. The current or and the unit, it should be in ampere, and then time should be in seconds. And then Z is equal to the electrochemical equivalent, or ECE. So for the Z is equal to the atomic weight or molecular weight all over 96,500 times the valence. So it should be grams per ampere second, or grams per, for the 96,500, that is actually the approximate value of Faraday's constant. And if you're using a Casio 991 ES plus, that is also the constant number 22 in that calculator. So let's try out number one. Okay, so let's try to solve this number one. So for number one, we have find the time take to deposit a coating of nickel 0.05 centimeter thick on a metal surface by means of current 8 ampere per a square centimeter of surface. So nickel is a divalent metal which atomic weight is 59 and a density of 9 gram per cc. So as you can see, that density is actually a volume density, judging by the unit. So because that is gram per cubic centimeter. So that's cube. Okay. So we have here the given is equal to this is actually nickel, right? So nickel. So let's list down all the things that we know in the nickel. We have the valence of a nickel is the one, this one you should know, this one is plus 2. And then atomic weight, okay, is equal to, I think that is already given. This is also the molecular weight. So 59. And then we also have the rho. So this is volume, okay? Volume density. Gram per cubic centimeter. Okay? And then we also have the I is equal to 8 ampere per square centimeter. Okay. In this case, we can say that the area here, assuming that the area here is 1 square centimeter. Okay? And the thickness of the coating, thick on a metal, so the thickness of a coating, thickness is 0.05 centimeter. Okay? So for the solution, first, of course, we will be using the M, or the mass is equal to Z I T. Okay? So we already have the formula for that, right? And then we can get that, since there is a given rho, remember that rho, or the volume density, is just equal to mass over volume. Therefore, we can say that M, right? M is equal to rho V. Okay, rho V. We already have the value for rho, and then we have to find the V. Of course, for V, this is just equal to the area times the thickness, right? Therefore, for the area, that is just 1, and then for the thickness, that is just 0.05. Okay? That is area times length, or base times area. Okay? So this is equal to, let me just extend this one. Okay? So extending that one, you'll have here V is equal to 0.05 cubic centimeter. So we already have B, therefore we can find M. M is rho, that's 9 grams per cubic centimeter, I think. Let's double check the given. Is it 9? Yes, is it 9? And then the V is 0.05. 0.05. Okay. Therefore, we can say that M is just equal to 0.45 grams. Okay, so we already have the value for M. Let's try to compute for the value of Z. Okay, so computing for the value of Z, we already have the formula for that, which is the atomic weight right, all over 96,500, which is the Faraday's constant. All you have to do is times this by the valence. So Z is equal to the atomic weight. Atomic weight of that is 59, right? Times 96,500 times the valence is. So getting Z is equal to 305.70 raised to times 10 raised to negative 6 grams per ampere. And then applying the formula M is equal to ZIT. M is 0.45, right? And then Z is 305 point uh, times 10 raised to negative 6. And then ampere 8. I think it's 8. Yeah, it's 8. Times 8. Okay, times. And if you use your calculator to solve that, T will be equal to 184. And that will be your final answer. Let's move on to the next topic.